So in this problem, there exists a conducting tube with two pistons, one piston with area A2 and one with area A1. Initially, the piston is in equilibrium. Let's see what forces are applied to it. So due to gas present in this chamber, the gas will apply pressure on the walls of the piston. Let's suppose the pressure of the chamber is P. Then P into A2 force will be applied on this wall in upward direction, and P into A1 force will be applied on this piston in downward direction. Simultaneously, a force mg will be acting on the assembly of two pistons, and because atmospheric pressure exists, so atmospheric pressure will apply a force on this piston assembly P naught into A2 in this direction, downward direction, and on this piston in upward direction, P naught into A1. So these are the initial forces that will be applied on our system. For equilibrium, the upward forces magnitude will be equal to downward forces. So we can write P naught A2 plus mg plus uh, P1 PA1 equal to PA2 plus P naught A1. So this is the equation of equilibrium. Now this assembly is displaced in upward direction with displacement of x. So both pistons will move with a displacement of x. One thing which is very important to note in this question is that the tube is made up of highly conducting material. See this line. Since the tube is highly conducting, this is the tube. So due to its high conductance, the change in temperature of the gases inside the chamber will be neutralized. Suppose the temperature of this gas chamber changes by delta T. That delta T temperature will be conducted through this tube. So the gas in this chamber will be maintained at a constant temperature, that is T, which will be equal to the atmospheric temperature. This thing is what we need to care of. This is very important. Now we can write PV equal to nRT. This P is initial pressure and this V is initial volume, and this temperature will always remain constant because the tube is highly conducting. Now when this system is displaced with a displacement x, so when the piston assembly is displaced by a distance x in upper direction, uh, then the volume of the gas chamber will change, and let's see how by how much magnitude it changes. So let's say initial volume is V, and final volume is V dash. So V dash equal to V plus A2 into X minus A1 into X. Uh, because you can see that, let me change the color. Because you can see this much volume of gas chamber is increased now as compared to before, and this much volume from the lower part is decreased. So this amount of volume can be written as A1 into X and subtracted, and this volume can be written as A2 into X, and this volume is added to the initial volume for getting final volume. So as A2 is greater than A1, so V dash is greater than V, because V dash equal to V plus A2 minus A1 into X, and this is greater than 0, so V dash is greater than V. Now because temperature is constant and PV equal to nRT, since temperature is constant and volume is increasing, so pressure will decrease. P dash is less than P. Now we have to write the equation of motion again. uh, we can copy our initial equation. Now see, this is initial pressure and final pressure P dash is less than P. So look at this diagram. The downward force mg won't change, P naught A1 won't change, P naught A2 will also not change. The only changing forces are P into A1 and P into A2. So on the left side of the equation there are downward forces, and on the right side of the equation there are upward forces. So P naught A1 will not change. Here P naught A2 plus mg won't change. Only changing quantities are P naught into A1 and P into A1 and P into A2, because pressure is changing. But PA2 is greater than PA1, so del PA2 will be greater than del PA1, because A2 and A1 are constant. The only changing thing is pressure. 2 plus mg plus PA1 minus PA2, P dash A2, uh, P dash A1 minus P dash A2 minus P naught A1 equal to m into A. This A is acceleration. Fine. This is the dynamic equation after displacement. So I can take common P naught. Inside the bracket is A2 minus A1 plus mg plus P dash A1 minus A2 equal to ma. Now P dash we can also write nRT, because T is constant, by V dash. V dash we have already found out, V plus A2 minus A1 into X. So we can rewrite this equation as plus nRT by V dash. Now I can take V common, So inside the bracket will be 1 plus a2 minus a1 x by v, and this quantity I can write as C nRT a1 minus a2 in by v into, I can bring this in the numerator and write power as minus 1. And we have studied the concept of binomial approximation. When this quantity is much smaller than 1, and obviously this quantity is much smaller than 1 because x is very small. So from binomial approximation I can bring this minus here. So 1 minus a2 minus a1 x by v. Now the equation of dynamics will be p naught a2 minus a1 plus mg plus nRT a1 minus a2 by v. Uh, if I open this bracket, I can write minus nRT plus nRT a1 minus a2 a2 minus a1 whole square by v square. Now look at this term. I can write this as nRT a2 minus a1 and bring minus sign outwards, uh, like this. And from equilibrium, let me bring this term down. From equilibrium, this is 0. We wrote the equilibrium condition here. See, from this equation, these terms will cancel out. So the only term left will be nRT a2 minus a1 square by v square equal to m x, one x is also there, x into mx double dot. So this equation is very well known equation of SHM, where x dot is directly proportional to x. So we can write omega easily. Omega is equal to k by m, where k is this term, and m is this. But before writing the final answer, we will simplify the k term, which is nRT a2 minus a1 square by v square. Let's see how we wrote. Uh, we will simplify it with the help of our equilibrium condition. So from this equation, p naught a2 minus a1 plus mg equal to p a2 minus a1 and pv equal to nRT. So v equal to nRT by p equal to nRT. Put this p here, which is p naught a2 minus a1 plus mg in the numerator a2 minus a1. Now we got the value of v. Now when we will put the value of v here, we will get our final answer. So this is our k. Simplifying it, nRT a2 minus a1 square by nRT a2 minus a1 square square and in numerator P naught A2 minus A1 plus mg squared. So this will be equal to P naught A2 minus A1 plus mg whole square by nRT. By nRT. So this is our k. So omega equal to under root k by m. Putting the value of k by k and m, what we will get, it's p naught a2 minus a1 plus mg whole square by mnRT equal to p naught a2 minus a1 plus mg by under root mnRT. This is our final answer.